Today we are looking at Chapter 1, an Introduction to Chemistry. This is a shorter chapter, and hopefully a lot of this is review for you. What is chemistry? Chemistry is the study of matter and the changes it undergoes. We call it the central science because you can see so many different sciences that kind of branch out from it, including physics, math, medicine, biology. So it really does play a role in so many different facets of life. Chemistry is everywhere. It's involved in probably more things than you even realize when you're cooking, when you're driving, when you are taking medicine, when you're putting makeup on, when you're drinking coffee. All of these things include relationships, bonds, breaking and forming. So chemistry is something that when you have an idea of the basics, you can really explain a lot of phenomenon that are going around you. Now we're going to hit the scientific method. The scientific method is a systematic approach to problem solving, and you've probably heard of the scientific method. Teachers do the steps in different orders sometimes, or different ways of wording them, but we're going to stick with these four main. Step one is define the problem. Usually you observe something and then you notify yourself that it's a problem. You then form a hypothesis. Remember, a hypothesis is a proposed solution, does not have to be correct. You then perform experiments, and experiments mean collecting actual data, and data can be either quantitative. Quantitative means you use numbers, or qualitative, which means you're using more things that are a little bit less tangible. So for example, the color of something, or something that it's tall or short, so you're not using an exact measurement. And then from those experiments, you write a theory or a law. So we're going to look at the difference between a theory and a law. So a theory is an explanation of general principles of phenomenon supported by facts. We always want to use facts to create a theory. Also, a scientific law is a concise statement that describes the relationship between a phenomenon. There's a large space there, please ignore that. Okay, so we're looking at theory versus law. Now let's apply the scientific method to a very practical application. Let's say your mom's car will not start. That is your problem. So what you're going to have to do is perform an experiment. Let's remind ourselves what an experiment is. An experiment is a procedure carried out to support or refute a hypothesis. Okay? So the first thing you want to do is form your hypothesis. For example, I would think when my car doesn't start that the car battery is possibly dead. So my hypothesis is the car battery is dead, therefore the car won't start. I'm going to perform an experiment. So for example, I'm going to change my battery. Or, of course, you could say, you could jump the battery, of course, change the car battery. Many options here. And my conclusion was, let's say after changing the battery, the car started. We would then say the conclusion was the battery was the reason for the car not starting. So pretty easy. Okay, so that's an application of using the scientific method in an everyday problem. All right, 3 phases of matter. So you are familiar with the 3 phases of matter. The definition of matter is actually anything that has mass and occupies space. So the 3 common states, we see solid, we see liquid, we see gas. You're going to see these letters S, cursive L, and G to indicate that in chemical reactions. So a solid is rigid and possesses a definite shape. And actually, even though it is solid, the atoms vibrate. So there is very small vibration going on in regards to the fixed positions of these atoms. The next one is a liquid. Molecules actually flow past one another, and they take the shape of the container. So as you can see in this container, they fill the Erlenmeyer flask up. And the last one is gas. Molecules move in constant random motions. They're always moving around. And they take the shape of the volume of the container. Now there is another phase, we call that plasma, but we're actually not going to discuss plasma in this course, especially because there is so much research still being done on it. All right, homogeneous and heterogeneous. Homogeneous is uniform in appearance, meaning it is all the same throughout. For example, a cup of coffee. Okay, it's all dark or black, depending on how you like it. Therefore, it's homogeneous. Heterogeneous is the opposite. It has two or more distinct phases. So, for example, if you had milk and cereal, or you had pasta salad, or you had a chicken salad, something like that, you can see the different components. That means it is heterogeneous. All right, pure versus impure. So pure substances, we call them elements and we call them compounds. And remember, elements are on the periodic table, which we're going to learn a lot about in this semester. And compounds are two elements together. Pure substances cannot be separated by physical means, meaning I cannot take a compound such as NaCl, table salt, and separate it by physically pulling it apart. I can't do that, okay? You have to have chemical means. So physical means cannot separate it. Impure means multiple components that can be separated, okay, by physical means. So maybe you can strain one, maybe you can evaporate a liquid off another one, something like that, okay, impure. So pure versus impure. All right, and the last slide of all of these lectures are going to just be a quick review, things you need to understand, things you need to know for eventually the test. So make sure you read through that. And if you have any questions, please don't hesitate to let me know.